Hi teammates! Today we are going to be looking at a few examples together in order to plot rational numbers on a number line using a scale that is not 1. So I provided both of our key points here and we're going to use them as an example. So let's look at key point number 1. When plotting rational numbers on a number line, you will need to identify a scale that is not 1. To ensure that you can do this, follow these 4 steps. So first, we will identify the given interval, or the distance between two values, and that's the numerator of the scale. So that means that our scale is going to be a fraction. You're going to identify the total parts in each interval, which will be the denominator of the scale. Then you want to make sure that you always reduce the fraction and then label each tick mark on the number line. So before we can get to this example, we are going to have to use our knowledge of key point number 2, which is to label. In order to label rational numbers that are presented in different forms, we need to convert decimals to fractions. We will do that by first writing the decimal as your numerator. The place value of the decimal is the denominator, and then we will reduce the fraction. So if we are looking at this example, it says let's identify the scale, and I am provided with 4 rational numbers. I am going to have to plot all of these rational numbers on the number line, so I know because of key point number 2 that I need to get them all into all of my decimals into fractions. So my first rational number, I'm going to write them all up here. My first one is 3.5. So it has a fraction in it. This is also known as a mixed number. Since it already has a fraction, I don't need to convert anything. My next number is, it is a decimal, it's 0.5, so that is 5/10. So I know that my number 5 is going to be my numerator. So key point number 2 says write the decimal as your numerator. So I'm going to write 5 as my numerator, and then I use my place value of the decimal as my denominator. So I know that this is 5/10, it's in the 10th spot, so my place value, or I'm sorry, my denominator is going to be 10. Now I need to follow the last step of my key point number 2, which is reduce the fraction. So I know that 5/10 can be divided by can be divided by 5 on both the top and the bottom. So I can divide 5 by 5 and 10 by 5, which would equal 1/2. So now I have my next rational number is 1/2. I've converted 5/10 into 1/2. My next rational number in my example is 1 3/4, so that has a fraction. It is a mixed number. And then finally, I need to convert 2.25 to a fraction. So I have 2 as my number in front of the decimal, so that is going to stay as 2. And then I know that I need to put my my decimal of 25. It's 25 hundredths, so I need to put that over 100. And then I need to reduce. So this is going to become 2 1/4 because 25 hundredths can reduce to 1/4. So my final rational number here is 2 1/4. Next, I need to identify what the scale of my number line is going to be so I can plot my 4 rational numbers. So all of my rational numbers are in fraction form, and I need to ask myself what is a common denominator of all of these rational numbers. I see that what some of them have in common is that some are some have whole numbers. Um, some of them have 1/2 fractions so that they have a 2 as their denominator. And then some of them have a 4 as their denominator. So I need to use some of my number sense and my understanding of fractions to know that if I have 1/2 and I want to convert it into fourths, I ask myself, how can I go from a half to a fourth? So I know that I'm going to have to multiply 2 by 2 to get to 4. And I know that anything that I multiply the denominator by, I also have to multiply the numerator by, so then I can have 1 times 2, so my numerator is 2. So now I know that 1/2 and 2/4 are the same thing. So I can actually call my rational number up here, I can call it 3 and 2/4. And then I can also do this with my 1/2 that's on its own, so I can call this 3/4. So you might be wondering, why do I need to make sure that they all have the same denominator? And that is because if I make a scale that is not 1, I need to make sure that the intervals between every number are the same and have the same denominator. So watch how I labeled my number line. My number line starts with 0 because all of my rational numbers are positive. So I'm going to draw 0 here. I know that the whole numbers that I'm going to be counting to, I know that I'm going to be going to 1, 2, and 3. So now that I already identified that the denominator is going to be the total parts between each number. So when I look at the number 2 in our key point, it says identify the total parts in each interval, and that is the denominator of the scale. So let's break this into our fourths here. So I'm going to draw 1, 2, 3, 9. And those lines there are representing the whole numbers that I know that are part of my rational numbers that I'm going to need to plot. And we saw that our common denominator is 4, so we have already established that our scale is going to be 1/4. So that means that I need to make sure that the space in between each number on our number line is going to be split into fourths. The way that I'm going to do this is count it by fourths in between my whole numbers. So I already know that my whole numbers are going to be 1, 2, and 3 because those are the whole numbers that we can see in our rational number list. And I know that I'm going to have to make tick marks between these whole numbers into fourths. So I know that I'm going to have 1 and 1/4, sorry, I'm going to have 1/4, I'm going to have 2/4, 3/4, and then 4/4 is going to make my whole number of 1. Then I will have 1 and 1/4, 1 and 2/4, 1 and 3/4, and 1 and 4/4 is going to be our whole number of 2. Then I will have 2 and 1/4, 2 and 2/4, 2 and 3/4, and 2 and 4/4 will be my whole number 3. And then finally at the end here I'll have 3 and 1/4, 3 and 2/4, 3 and 3/4, and then finally right here I have my whole number of 4. Okay, so I went ahead and did my best to label these. Sorry if some of them are a little difficult to read. I was running out of some space, but you can see that for each space in between the whole numbers, we have our scale of 1/4, and we can see the whole number before our fourth. So we have 1 and 1/4, 1 and 2/4, 1 and 3/4, the whole number 2, 2 and 1/4, 2 and 2/4, 2 and 3/4, and so forth. So the last thing that we need to do here is just plot our rational numbers on the line now. So we can see that our first number is 3 and 2/4. So let's find our whole number 3 and count our fourths. So we have 3 and 1/4, 3 and 2/4. So let's plot our point right there on 3 and 2/4. Okay, our next number is 3/4, so there's no whole number in front of it, so we're going to look between 0 and 1 to find 3/4, because it's not even the whole number 1 yet, it's just 3/4 of 1. So let's take a look. We have 0, 1/4, 2/4, 3/4. So let's draw our next, or plot our next point here at 3/4. Our next number is 1 and 3/4, so let's find our whole number of 1 and count our spaces to 1 and 3/4. So we have 1, 1 and 1/4, 1 and 2/4, 1 and 3/4. Let's plot our number there. And then finally we have 2 and 1/4. So let's find our whole number of 2 and then find 2 and 1/4 by just counting into that second fourth, or that first fourth there in between the 2 and the 3. Great. So now we have plotted our all of our rational numbers. Really great job with this problem.